for the last 3 months in the QA, question answering part of NLP, and I will talk about that. And before I talk about my experiment, I would like to talk about some intro stuff. And I don't know, because of the audience, how much you're familiar with the terms like QA or NLP or even the LSTMs and sort of thing. I'll just touch upon those, and then I'll get to some of the research that's been happening for the last couple of years, and then talk about my research, and then I'll try to answer as many questions as you guys ask, but I'm not the smartest guy, so some of the questions I think I said pass, and maybe I'll get your email ID and then answer the question later. Yeah. Before I get into the whole stuff, the term Mahabharat I think may not be familiar to all of you guys. In the question answering section, we thought we will take a data set which has been not used by anyone, and also such a data set which has been completely in its original pristine state, no curation, no human manipulation on the data has been done, because that's what exactly, if I use my proof of concept in the real world companies, the text and the amount of documents available, you just don't have time to actually manage that. Mahabharata is an Indian mythological epic or a story. It's a massive document. I found the copy available online. It's actually 18 chapters. I only could work on around 11 chapters. It's not a huge data set. I'll talk about something called CNN data set and Daily Mail data set, which is one of the problems people have worked on. It's not that massive, and I do know the correlation between the size of the data set and the accuracy of the model. I understand that part too, but this is more of a proof of concept I'm working on. So out of the 11 chapters, it was 55,000 sentences or lines, and I think around 25,000 tokens and stuff. We got a good result. So the reason why I'm happy to stand in front of you guys today is we got a good accuracy rate. And unless I've made a terrible mistake in my bug and my program, and then it's really showing something high, which I've done a little bit of testing here and there, and I'm confident that I think it's not a bug, but the accuracy is better or similar to, at least compared to the reports published, I think, in 2015 and maybe a little bit of 2016 by Stanford and some of the researchers. And with that segue, I would like to talk about one gentleman I met in the conference just last week, Richard Socher. I even told him that you are like a god for all the NLP enthusiasts in the world. I think he has done a tremendous amount of research in that. And I was telling him that one of the papers you published, I think 2015, 2016, I seem to be getting better accuracy rates, even though I've not done any of those techniques or the models or the parameters and what you've been talking about. So he didn't show much interest in talking to me about that, but he was kind enough to accept my connect, and we will talk a little more about that. But if you have not heard of Richard Socher, I would urge you guys, because you're all NLP enthusiasts, you should find out who the guy is and what he's been doing. I think it's done a tremendous amount of work. And a lot of other guys too, like Andre Kapati, I think is another guy who's done a lot of work in NLP. But okay, let's talk about, to set the tone, I'm not sure about how much you know in NLP itself. I'll talk about it. QA, question answering, has been one of the most important activities been going on for the last 1 or 2 years. Even though models like RNN and the data sets available for the last 3-4 years maybe, and maybe infrastructure like the GPUs and TPUs being available of late, QA, question answering, has becoming a lot more popular over the last 2-3 years, not before that. And hence the accuracy rates of the models, and even the complexity of the question, and hence the complexity, the answer you will get in response is not that high. I'll talk about, we have adopted one of the simplest problem statement where if you ask a question and the answer is a one-word answer, the model actually predicts with a good accuracy rate. But I met with a company the other day where they're working with a legal firm. They are looking for answers for a little more complicated questions. For example, if I get into a traffic accident and if I leave immediately, would I be penalized for it? Which needs some amount of tabulation and analysis of the question, tabulation of the data available from multiple sources and putting it together. I don't think anyone has actually solved that problem yet, but there are a few papers published till now where if you ask a question to identify who the person you're referring to, or what the person is doing, or where the person is, I think those type of questions have been intelligently addressed using the RNN models. That's a QA. Word embeddings is another major concept which has actually brought NLP to the forefront. I think in 2013, Miklov and all other guys found this new method of identifying word embeddings using word-to-vec. That was the spectacular leap in the growth of NLP, and I believe whether it's word-to-vec or GLOV, I think it's really contributed a lot for NLP. Before that, even though there were other models like LSA and NDA available, but I think which is not. And in the word embeddings, in my experiment, and which I would like to share it with you guys, and if you have any different comment, I would like to know what you think. We used one-hot vectors, and we also used word-to-vec vectors. We did not do GLOV vectors. And the common sense, at least I thought before I did the experiment, I thought the accuracy rates are going to be better with word-to-vec compared to one-hot vectors, because I can explain why one-hot vectors don't capture all the semantic information, but word-to-vec does capture the semantic information. I thought that we should be more intelligent, but we were to a surprise, but I'll talk about that. LSTMs are another type of RNNs for, I think, at least a couple of reasons. If you have the context long enough, let's say if you're talking about a sentence or a paragraph or a document which is long enough, RNNs don't capture the dependencies as effectively, and also they have the vanishing or exploding gradient problem, and hence LSTMs were invented. I think even though theoretical LSTMs were there for a long time, but the implementations of LSTMs has been there only again for the last 2 or 3 years. But after that, there's so many variations of LSTMs. Actually, if I say LSTM, there's nothing called LSTM, because there's every paper published after that, every 2 months, the definition of LSTM is changing, and hence I'm picking one particular style of LSTM, but there are so many different LSTMs. Long, short-term models. I'll touch a little bit about the LSTMs, and of course there's an extremely nicely written blog, if you guys are not aware of it, by Kola. Christopher something, what he calls it, Kola. Unlike RNN, which has only a single layer of transformation of your input data, you have 4 layers in LSTM. A lot of magic happens inside, even though you have terms like 3 gates, input gate, forget gate, output gate, and you have transformation, you have cell state, you have output. At the end of the day, I want you guys to take away that LSTM gives 2 outputs. One is the output and the other one is the cell state. Both of them effectively capture the information you have fed into the LSTM in the previous few time steps, T. And how long can time steps be? There's a lot of research happening still. If it's a shorter time steps T, I think it's more effective in capturing the information, but if it's longer, I think it's not that effective. We have these LSTMs. Of course, if you feed forward LSTMs, when you start with the first word and end with the end word, then sort of a feed forward, and then you also do the reverse where you end with the last word and input and come to the first word, and it's called a reverse LSTM. And then that's called bidirectional LSTMs. We've used both, and I'll talk about what we've got. In the QA, question answering, or even machine translation or similar sequence-to-sequence models, typically, this is pure theory, there is an encoder and there's a decoder. Encoder is an LSTM which is encoding your inputs into certain outputs and gives it to another LSTM which will decode, which is another, it's called decoding all the information. So the encoder gives out 2 outputs, a hidden state. Hidden state is actually dependent on the input, xt at any point of time, and the hidden state of the previous timestamp. And the output vector is dependent on all the hidden states. That's the encoder, and then of course you have the decoder which actually tries to predict the output based on all the previous output at a certain time, based on all the previous outputs and the output vector from the encoder. Again, if you are newly introduced to NLP, I would say a lot of magic happens here again, and you do the inputs, the words are fed into the encoder, and then it gives out an output vector. You use the output vector and starts predicting what the next word is. And typically, people when they're trying to do machine translation or even question answering, they want to predict what the answer is for the question.
Quick question. So, what are X1, X2?
X1, yes, these are all each word. Let's say if we have a sentence of 10 words, X1 is the first word and the second word and the third word, yes.
But usually they're embeddings, right?
Yes, here in the mathematics, these are the words, but X is actually the vector embeddings of the word, yes, yeah. But when you talk about implementation, I think I can talk about how the implementation is done, but I think these are words being inputted into an LSTM, and then you get a vector outside, and then you use that to start predicting the words. This is I've just got this picture, I think, got it from TensorFlow. This is another variation of an encoder and decoder shown in a very minimalistic picture, but this is actually a stat. You have 3-layer encoder and decoder, which is pretty much doing the same, except a minor variation. I think I mentioned to you earlier, there's so many variations, so each paper has its own variation. The decoder don't get the inputs in the previous model I was showing. In this case, in TensorFlow, in the sequence-to-sequence model, I think based on certain paper they're quoting, they feed in the inputs again into the decoder too, along with the outputs of the encoder. But again, that's the algorithm they're using, and if you want, we can talk about which one is more efficient, less efficient, but there's so many variants available. These are the 3 papers I've been really attracted to, and then teaching machines to read comprehend is the primary paper that really triggered my attention. Of course, studying a bunch of other papers, but if you want to really find out which area we focused a lot more, these are the 3 papers which helped us in understanding the problem statement and also defining some sort of algorithm how to solve it. So I will explain the models, the authors in teaching machines, and the authors in this paper they've taken, and I'll talk a little bit about what type of solutions they've used and what type of accuracy rates they've got, but then I'll talk more about what we used and what we've got. Okay. So typically the question answer is, in teaching machines to comprehend text, what they've done is they actually took data sets which were news items published by CNN and also by Daily Mail. Because they wanted pre-existing data sets which has some story and some type of question, they found CNN, when they publish a news item, they also have summary of the news item, not necessarily using the same words, but they summarize the news item in a few bullets, 2 or 3 or 4 bullets. So they have taken that data set, so the main news item as the story and the bullets as the question. And they want the model to predict the answer for the question which is based on the story. Such data sets don't exist, so this became hugely popular, CNN data set and Daily Mail data set. So this is how it looks. You have a typical story, it's a long story of course, I just shown a little bit here. And then this is the summary bullet statement. And the authors, what they do is to make this a question, they replace one of the words, typically a noun or a person, and then they want the model to predict what is supposed to be in X. So that becomes a question, and then the model predicts the answer. Now, sometimes the answer may be in the question, and they don't want the model or people to use, who are using the model to think that, oh, the model predicted the answer because the answer is in the question itself. The authors have actually replaced all the major entities in the story by random placeholders, and they do the same thing with the question too. So that when you feed in the context and when you feed in the question, the model has to understand the question in the context of the context given or the story given, and then figure out what the answer is. And they have around 300,000, 400,000 story query answer tuples. And these placeholder entities I can see it here. Someone's hacking, maybe? Maybe put in here stuff. Maybe they figured out there's no money in this, so it's not hacking. So these entity, the placeholder terms, after every story they again juggle it. So even the model cannot memorize the placeholder mapping with the right word. So that's the approach they've taken, and I don't have the actual data how much they've taken, but then CNN dataset, and they were on 300 tuples of story, query, and the answer. And in Daily Mail, I think it's close to 1 million data set of story, question, and the answer. This is the second paper, the Goldilocks Principles, reading children's books, the explicit memory representation. It's a different paper. They have taken an approach where you take this whole story, identify, let's say, 20 lines. The first 20 lines is the story, and the 21st line is my query. And I replace one word in the 21st sentence, and the model has to predict what is that word. In a very few instances, the answer is already in the question, but that's very, very few instances. And you can actually run an algorithm before you use the data set to eliminate those tuples of query, the context query and answer, which has where the answer is also put in the question. And we have taken a very similar approach, but let me explain the various models the authors explained, and then I'll talk about what I've done. And the reason I want to show this and then talk about my model is these are complicated models. And again, we have taken an extremely simple model, and still we got a decent accuracy rates. Again, as I said, if you're really good programmers, please come and look at my code and see maybe there's a bug, and that's why I'm getting a good percentage accuracy. Let's talk about this. The simplest LSTM model. They actually have a two-layered LSTM. There's no encoder and decoder method here in this model, but they actually used it in the attention models. They concatenate the context and the question. Of course, they put a delimiter between the two, and then feed in the entire text into the LSTM here. So, for example, so they're feeding the question first, and they have delimiter, and then you have the context going. Of course, this is a small context, particularly the long one. And they've experimented on the reverse side too, where they first feed in the context, and then the delimiter and the question, and they got approximately the same accuracy rates for that. So that's one method. It's a plain vanilla LSTM, two-layer LSTM. They feed in the data, and by the way, they've used glove vectors when they fed in these the words, and when we did that, it was one-hot vectors.
This is single directional LSTM?
Yes. This one is single direction. Yes. That's of course the simplest plain vanilla LSTM, and the next one is an attentive reader. They've used a bidirectional LSTM. Number one, they have taken the approach of encoder and decoder, and they have used the attention mechanism. And if you're not familiar with the attention mechanism, I'll explain in a very simple term. In this approach, you feed in the entire text, that is the context and the query, and then based on the output, you predict the next word, which is the answer. But in the attention mechanism, for every word you're predicting, how do I explain that? So this is the query, and this is the context. You have a bidirectional LSTM. The outputs of every LSTM you take a weighted sum of you take a weighted sum of the outputs from the encoder compared to the query, and I'll show you the equation. So in other words, every time you feed in the new word, it goes back and checks in the context which of the words in the context are relevant to me. For example, Sally went to the kitchen, she wanted milk. The word she, when the encoder encounters the word she, it goes back and checks which word should I focus to understand the word she. And she went there. Let's say Sally went to the kitchen, she went there because. There again, it goes back. What is meant by there? It goes back and checks which word to focus on. That's the meaning of attention. So it goes back constantly to the previous context given to the model to understand what it is. And the paper actually even shows in a graphical view, every time a new word is predicted, it actually shows which word it's focusing on. I may have a graph of this slide. I have a view of the graphical view of the attention model. So that's the attention model, where in the attentive reader they use the attention model where they just take for the entire query which is fed into once, they don't do any more processing, and then after that every word predicted in the encoder is they try to take the weighted sum of all the predictions based on the current prediction and the query. But in the impatient reader, instead of reading the entire query, they are actually taking each and every word when it's fed. It compares, it takes a weighted sum of the predictions of the encoder. So in other words, every time you have one word of the query being fed into the LSTM, it actually goes into the attention model to pick which word or where the context, where I should focus for this word. So that's the attentive reader. I just picked that up from a different paper, but just it shows more effectively the paper, the message. So you are inputting various words in, and then of course it's a bidirectional LSTM, and then you actually have outputs coming up from the LSTM, but you're taking not the entire output, but you're taking certain portion of the, so you're taking a weight that's called at cost of attention. You're actually taking only a portion of it, and what portion of this, whether this or this or this, depends on your previous state and the word you're predicting.
One question. In order to learn this attention, what kind of supervision is provided?
There's no full supervision.
So it is completely autonomous and unsupervised?
Yeah. Well, let me take it back. You have the data set which actually has the context, query, and the answer. So in the training mode, you are giving the correct answer. So it actually emits an answer, and you have the right answer and does a back propagation, and then I adjust the weights.
In your training data set, do you have wrong answers, right answers combinations as well? Or
in this paper, I have not seen wrong answers. They're not introducing any noise there. I think you're referring, the word is noise there. It's always the correct answer. If you actually have the correct answer, it adjusts. If it's not the correct answer, it just
so that it learns everything by back propagation?
yes, yeah. It takes a back propagation. This is a graphical view of the attention model where it's showing where the model is focusing currently based on what is the current output of the encoder and what is the state. Anyway, I think the cost, even though attention model, sometimes there's a debate going on in the NLP world, the attention model is something similar to the memory model where you're actually storing information in the hard disk of what the context is, and you're going back and checking everywhere. There's a little bit of research going on, but I'm not aware of the intricacies of whether it's which one is a memory model, which one is attention model. Another problem with this attention model is the cost of computing. There's so much of computing going back and forth happening, unless and if you have more data, it's going to take more time. but I think that this seems to be showing better results in their model. Actually, they published the results of plain LSTM, attention model, impatient reader. The accuracy rates of impatient reader is better than attentive, and that is in turn better than the plain LSTM. These are the equations for LSTM. So for the query, you have a single one-go output. The output for the query for the one direction concatenated with the reverse direction. So you have two outputs. Q in this direction, the last word, the last output is the Q, whichever is the last word, and this is the last word in the reverse direction is word number 1, and you get the output query. And that's in the attention model, you just do one go, and then for the input, every timestamp you take the output and the vector representation of the document is based on the outputs at every time, and then you take a weighted summation of those outputs. That's the attention model. Again, there's a lot of mathematics here. In the impatient model, it's almost the same, except in the query, the entire query is fed into the LSTM in one go, whereas in the impatient, for every word of the query, you do an attention model, and the rest of the model approach is the same. This is a different paper where they talk about dynamic memory networks, written by, I think this is written by Peter Socher and a bunch of other guys. Here they show, you have this, let's say if your context is multiple sentences, you have multiple sentences being fed in. Each sentence ends with a sort of a delimiter. In this case, just I think is a period. Once the model encounters the period, it computes one single vector, output vector, for the entire sentence. And so that's from the input module, and then you have a question module where you have one single vector from the question module. So every time it computes one sentence in the input module, the output vector of the input module and the output vector of the question module are combined to create something called an episodic memory. So every sentence plus the query, the question vector, is called one episode, and every time that such episode happens, it actually creates an episodic memory, and they process all the episodic memories to find the answer, to predict an answer. You should read the whole paper, I think, to understand what it is, but just to summarize, the plain vanilla LSTMs, you feed in the text and then you get the outputs. Then second approach can be you have a plain vanilla LSTM with an attention model, and then of course you also have the impatient attention, where you, for every term, every token in the query, you do a attention model. Coming to our approach, we have taken extremely simple plain LSTM. We have a small data set of 3.5K context, query, and answers, compared to 300,000 for CNN data set and a million, close to a million. We have used one-hot vectors, and we also used word-to-vec vectors, and I've used one-hot vectors of dimensions 1K and 2K. And then one-hot vectors, we did a combination of 100, 300, 500. I didn't want to go to 1,000. I was not using a GPU, I was just using my desktop, and it was taking, every time I do a training a model for 500 dimensions, word-to-vec vectors, it was taking maybe a day. So obviously I can't play around too much with that. Yeah. We have used both LSTMs and bidirectional LSTMs. I have used a range of hyperparameters like dropouts, for example, 0.1 to 0.5, regularization I think 0.1 to 0.7 even. I've used a bunch of other optimizers other than Adam and Adagret, but I think the other ones were giving so bad numbers, I just dropped off that. Activations also. I've used ReLU and sigmoid. We have taken the approach of 20 lines, and the 21st line is the query, and I've also taken a different approach of 10 lines being the context and the 11th line being the query, and we replace the named word and then find the prediction, make prediction what the answer is.
Question.
Yeah.
So if you have 20 lines, 21st line is the query, and then again next 20 lines is context, and the
Yes.
42nd line is the
Yes. So 20 plus 121. So 22nd to 42nd, and the 43rd. Then 44th to 64th. Yeah, 11.
And
If it's the same 10 means you'll be 1 to 10 plus 11th one, and then 11, 12.
so this is your training set.
Yes.
What is your test set?
What I've done is, out of the 11 chapters, let's say each chapter has, just for ease of mathematics, let's say 1,000 lines. I have put 200 lines into my test set. So while training, the model would have never seen that context, those questions, and those answers.
But which 200 lines? Randomly chosen?
No, I picked the last 200 lines of the chapter.
Every chapter.
Yeah, every chapter. So it's not one all the way down, but every chapter I picked the last 100 lines. 20% lines. Yeah. What else I did? So we work with 10 lines as a context. We work 20 lines. I did not try 50 lines.
And sorry, one more question. Your evaluation is if you do say stochastic variance and you go through the data set once, then you do the
For every
evaluation.
batch. For every batch.
So when you train on every batch, you do
Yeah.
the evaluation on every batch.
Yeah.
Until you begin this.
Yeah. So we had a batch. I had a batch of 128 items going in. One more data point. I'm forgetting what I want to share. Yeah. I think I'll talk about the padding because vectors need to be padded because they all have to be the same matrix size, and we had a little bit of a problem there. Yeah, interesting part. The story, because the data set we picked was such that this is of course an Indian mythological story. It's not really similar to some other the business type of documents you find. There were some sentences which were as long as, let's say, 30 words, and there were sentences, there were only some 4 or 5 words. Because I was training on the number of sentences, sometimes I find 600, 700 tokens in my context, and somewhere maybe 200 tokens in the context. And because I had to have the same size vector, if I pick 200 as the first one and the 600 or 700 words as my second input coming in, and both vectors ought to be the same size, then I'll be padding with zeros. But then there'll be so many additional zeros, and I had to pick contexts which were between a short range. So I used to pick between 220 words to 260 words. Any context which is out of that range, I used to discard. One experiment I did not do is we were padding the zeros all the time at the end of the vector. We are yet to work on if I pad the vectors, the zeros at the top and then the rest of the vectors at the bottom, maybe the results will be slightly different, but I have not tested that.
Also, this one-part embedding that you mentioned, this is for every word, right?
Yes.
So even if it is not a named entity or anything like that, so it's a verb. You got up.
Yeah.
So got will also basically create a vocabulary and use.
Yes, yeah. So what we've done is that we actually had a corpus of 25,000 tokens, and I think we brought it down to 1,000 and 2,000 vocab size.
How do you do that?
We eliminate the most frequent and least frequent, and then that's another problem we had too. When I did the basic Excel graphs of just the frequency of the tokens, almost 10% of my data sets was only occurring only once. So I have this conundrum that should I use even those two or not, because it's 10% of my data set, and those are all important terms. When I looked at individually the data, I felt these are all important ones. So I actually, when I did the vocab selection, I picked the frequency greater than 0 to less than 1000, less than 2000, whatever. Then I try to bring the vocab size to that 1000 and 2000. But that was a unique situation where what to do when you have one, the frequency is only ones, and if you have such numbers, large number, how do you do that? Richard Socher, I think, talks about that. I think one of the video I've seen, I think he was talking in the Stanford presentation, I think he talks about that. There's no other choice other than actually including them too, to compute your training, to train a model, to get some decent rates. Anyway, here is my results. Using just plain LSTM, I got something more than 70. And of course, I was running multiple batches, and that's on the x-axis, and the percentages on y-axis. Even though the loss was almost steady, the accuracy was actually fluctuating. And the interesting part was the training accuracy and the testing accuracy was very close to each other. I think it was 62. Yeah, it was 62%. Questions?
The y-axis is the accuracy,
Yes.
and the x-axis is the length of words. What is
No,
the
x-axis is the number of the batch number.
Just the batch number.
Batch number. Yeah. So by the time you do the 22 batches, I'm done with the whole data set. Yeah.
Why is the first column, I'm guessing it is some kind of mini batch number?
Here?
Yeah, the first column.
Yeah, this is the size of each. What is it? Yeah, this is the size of the context. As I said, I took a range of. I think this sample I would have taken, like, let's say 400 to 450, something like that. I would have taken a range.
And how are you getting an accuracy number after every context? You don't have multiple questions, right? You will have only one question, which is the 21st line after a particular context. So why are you getting a number like 9.51, 6.9, 3, so on?
So this is after each batch. So there are 22 batches. Each batch may have around 100, 200 tuples of context query in question.
Okay.
So I do a back propagation after the batch is done, and then it does a math of how much was the loss and what is the accuracy
Over all the questions in the batch.
in that batch, yes. And I keep on feeding the information, the new batches with untested data, and then the accuracy fluctuates over a period of time. And for the last, I think, from the 19, 20, 21, 22, is when I think the final data set. So 22 batches. And the accuracy, that's what the accuracy is. If you guys can actually, I don't know, I was surprised to see the loss. There's not much of change in the loss. I was trying to talk to people and trying to find a correlation. I've not found any scientific correlation between how much would be the loss for the accuracy to fluctuate or go up or down, or should the loss be fluctuating similar to the accuracy or not.
Did you try measuring AUC or whatever?
Not.
Also, is the test set behavior pretty similar to this?
Yes, it was 62. The testing accuracy was around 62, 65, 66.
But as you mentioned before, you would do every batch and then you do a evaluation of the test data set? Or would you finish this experiment and then just do final evaluation of this data set?
I finished the training first, and the model is trained, and then I have a different data set to test on it, and then I get a different data set.
Then you said one.
No, they have, I think it's the data set is around 20%, so I have around 7 or 8 batches in that.
Oh, you divide the batches and then you calculate.
Obviously, I cannot put the whole, the entire data set into a single batch. I just made it a multiple batch. See, for testing purposes, it doesn't matter whether it's a small batch or a big batch, because you're not doing any backpropagation, you're not doing any such things. You're just putting inside and then trying to model to find out what the answer is.
Like some experiments that, so I work at LinkedIn. We've been trying to do very similar experiments with not LSTMs but generally specified models. And it is very different if you, so for example, if you do different parts of the, so suppose I call this an epoch, and you have multiple mini batches in an epoch, and you do say 10 mini batches, and then you do one of the test evaluations, and again do 10 mini batches, and do other test evaluations, so on and so forth, then your test performance changes significantly. And it is not always true that if you do the entire training first and then just do test evaluation once.
You're not talking about validation, are you?
So I'm using the word validation and test in kind of an interchangeable.
Yeah, that's slightly different. Yeah, when you do the training, of course, you actually put some training data, the training data on the side and do the validation to make sure that everything is fine. And then when the model is trained, and then you do the testing. Because when you're doing testing, you don't have any more of those backpropagation happening, etc. You're just testing and finding out whatever the prediction answer versus you check against the correct answer and then compute the accuracy. You talked about epochs. I think I have a finding there too about how many epochs are required to run. But before, let me show you the results of BioLSTM too. Very interesting. I have very similar results in BioLSTM. So I've actually had 5 BioLSTM models trained with this, and I actually have another 5 LSTM models trained with various hyperparameters. Each LSTM will be having different hyperparameters. For I think 2 BioLSTMs, for unknown reasons, they were giving a 0 accuracy rate, and I need to go back and check, because the loss computation is always cross entropy, and which I was using for both LSTM and BioLSTM. So that was not the reason, but I think it's a combination of an optimizer, regularizer, and activation function. Maybe some combination was really throwing off the whole BioLSTM, but for some reason, all the LSTMs were giving decent rates. Let's say 65 to 72 was the LSTMs, but BioLSTMs were giving the same rates except a couple of BioLSTMs. So I found bidirectional LSTMs were not as reliable as I thought.
You used ReLUs as activation.
See, the most common used activation is ReLU, but I've used other activations too. But yeah, and I think I mentioned it. I think the next slide I have the mentions of the hyperparameters and stuff.
I was just thinking if it's on the dead ReLUs.
Sorry?
I was just thinking if it's in ReLUs.
I use ReLUs too. Yeah.
Get dead. No, if early on they get dead, they won't activate.
I don't know.
Did you do any comparison on the error types to see if there's a certain category that there were errors in, so you could have more data?
Could you tell me what type of errors when you say errors?
Like if you look at the ones that, the questions where they answered it wrong, if it's a certain type, like if it's a certain type of words or type of questions, and then you add more samples in.
Good point. So I did that. When they were right or when they were wrong, was there any correlation between the answers? I did not find a strong correlation. They were all on the across the database. Again, maybe that's the uniqueness of the data set. There were complicated words in the data set which were long words. Maybe I think they were on 20-25 character long words too. But again, the word frequency was only 1, sometimes even 2 for some of these answers. And the model, of course, did not predict as accurately for the low frequency, but I found in a few instances where for even the low frequency words too, the model predicted answers correctly. So in other words, I did not find a strong correlation.
And you didn't really take like the part of speech tags?
No.
So one question, when you do the evaluation, even in the training data set, you would take the 21st line as the question. Would you do something similar to what was shown in the example, that you make a particular thing X and try to predict the next?
Yeah, that's what we do. So what we do is we replace a word with a placeholder word, and we actually would have converted that also into a vector, and then it has to predict what's the placeholder.
So is that placeholder chosen manually, or how was that?
No, we do the name. From that context, we're doing an NER and POS tagging there, and then we replace a specific name. Yeah, there we're replacing a noun.
So
With part speech.
Yeah, it's POS. Yeah, we're doing POS. Yeah.
So when you do the evaluation, even if it makes a mistake, did you check whether it was trying to predict a named entity, so a noun with another noun, or was it just picking random words when it was making it?
I need to go back and check. I don't know. No, I did not check that. I did not check that. But when I looked at just the answers where it's predicting correct and wrong, is there any trend it's picking up? I did not see a trend. But is it just replacing with one noun with another noun, etc.? I didn't check.
Because in that case, it at least means that it is be able to pick up
Some
parts of speech, something like that, without any supervision of that.
Yeah.
For the training. it's
It makes sense, but when I use when I use a practical application of it, doesn't matter if it's a wrong noun, even if it's a noun or it's a wrong noun, then that's not the correct answer. I'm looking for the correct answer, and if you make a mistake, then I think the accuracy is low.
I mean, what I mean is, suppose it confuses Vishnu with Drona, it means it is understanding the context.
Yeah. Sure, I get your point. Yes, yeah, I don't do that.
What was the corpus that you used to train, to do the vectorization?
How big?
Train the words back, embeddings.
What was the question? How big the corpus is?
Yeah, what was the corpus that you used to train the word to back?
So I found it online. It's a 55,000 sentences corpus. It's a story, an Indian story. So that's the whole corpus, 55,000 lines. So around 25,000 unique topens. And
Completely separate from this volume of work here. It's a separate book, a separate story.
no, that's the story I worked on. So my experiment is that on that corpus. So creating the word to vec, the vectors.
So the 11 chapters, or whatever you said. You trained. Did you remove the 200 out of 1,000 lines for your test set before you did the word to back embed?
No, for word to vec, you do the entire corp. Word to vec, it's actually an extremely simple thing. You just give the file name and then say word to vec, and it just creates the model, save the model and done. But if it's one hot vector, then you have to identify what the vocab is. And actually I made a vocab of only 1,000. Then I actually have the dimension of my one hot vector for each word is 1,000.
Technically, your test set is influencing the word embeddings before you remove the test set to do the training.
Okay.
Well, we said that.
I mean, in future questions, you won't be able to, they're not included in the embedding, they don't affect the semantic space, right?
No. I have when I created the word to vec, I'm using it on the entire corp.
Yes.
Entire
Yes.
corpus.
Then you
And I'm saying that's a
use-
source of data leakage, because now the test is influencing the word embeddings before you remove them. Their presence is there, and so.
Well, if you're only asking the question
But-
about the story, that particular story, that's not the problem. Like, you need visualization for the suffer, yes, but in this case.
But some of the words repeat. Both my training and the test. How would I eliminate?
No, ideally you should potentially just do everything either the training data set or a completely different data set, just like related. So basically, that's why when they want to do word to vec training, they'll probably take daily in corpus for a long period. Which
Sure.
in your case won't work well.
It won't work. But then if you train the corpus on certain words, and if you ask in the testing, if you ask a question, and the answer happens to be a word which the model has never seen or even heard, or vector does not exist.
So that is probably not a fair question to ask. Should you use it with that?
Okay, maybe I'll talk to you
I
offline.
realize
Because,
you drop out those words and put those with context.
yeah. For me, I had to do the entire corpus because I think model has to understand there has to be a vector for a word, because I think when the model predicts an answer, there has to be a word for the vector, otherwise I can't. So yeah, but I can talk to you guys offline. Thank you for the comment.
If you, so is the text, I'm sorry, I'm not very familiar with the text itself. You mentioned it's like a prominent text within Indian culture. Is it like religious text or?
It's just fictional story. It's a story.
Okay, so
It's
it's
just a story. Yeah.
like, got it, okay. So could you take other similar texts from whatever time period maybe, or similar types of text, use that as the training?
For the same model, I thought about that, but if there is a comparable story. I don't know, some of you guys, if you know Indian, similar to Mahabharata, there's another extremely massive story. I would have taken that, but then
The nouns.
if the model has never seen the answer, never heard the word.
For instance, yeah, so what I'm saying is if you're able to identify other texts that would have a high overlap of
Yeah.
of words.
The proper nouns might not work at all.
So the
Yeah, so obviously the proper nouns
Yeah.
are kind of out, right?
But also
But
the
that
one
is-
hot.
will heavily depend upon the fact that you have some kind of, so that's how the notion of nearness, etc. forms can work, right? Because if two entities are occurring very close together again and again, then you know that those two entities are related.
Yeah. I think maybe you're referring to, let's say if it's a legal documentation, then I think you can have a lot of correlations and you can take 1,000 legal documents for training purposes and then 100 legal documents which are never touched could be used for testing purposes. In this case, unfortunately, I think it's one cohesive story. If I take any part of it out, even like the comment you mentioned, the nouns actually exist in some other part of the story too. I think it,
But this is in contemporary English.
yes, yeah.
So the interesting thing would be to know if how word were compared to the one hot. The one hot wouldn't have learned.
Yes, yes. That's coming in my next slide. But I think going back to your comment, contemporary English, it's actually not exactly modern English. So I actually see the words like "oh king." So I have this "o" and then "king." So I have a vector for "o" too, and eventually it figured out, okay, whenever the "o" occurs, I think there's to be either the word "king" or the name of a king, maybe in this case, Ishtar or whatever. So it figures out, but. So it's not really contemporary English. I think it's more of
So is it when you say contemporary English, it's a translation?
It's a actually it's not. Let's use a
Or
different word.
modernization?
It's not a modern English. Let's say it's a little more medieval type English where, "O King, the Almighty,"
But the original text is written in.
This-
not English.
Oh, so it's yeah. So there are multiple translations.
Of course, yeah.
So what would happen if we take different translations and put them
I can try that.
in the
Yeah,
track?
yeah.
Because then you have overlapping of proper nouns, but you also have emergence of like interpretation perspective. Like I don't know.
But I think
But I'm not sure about
training
what is the
suggests that the issue that he was talking about has got nothing to do with that.
Okay.
It's more to not include whatever. If you left out some information that it is supposed to make sense of, you should not be doing anything from that information.
Okay.
Yeah, essentially the word the vectors are learned some similar answer.
Okay.
So if you're encoding proper nouns into this word to way, then you're always going to face this problem, right? Regardless of what problem you're trying to solve, whether it's a legal problem or real estate, proper nouns are never going to match. So you're essentially saying that if you're doing this on a legal corpus, use the whole corpus, train your word to way, and then do the question answering. That's not very scalable. It doesn't sound very scalable.
It does actually. It could be a noun or whatever it is. You pick, let's say in this case, a noun or noun typically, and then you have the vectors created for the entire corpus, and the model figures out. Eventually, it understands based on the weights and stuff. When you give it a query, it outputs an answer which with certain accuracy, which is the right answer. So whether it's a legal document or noun or otherwise, I think the model, I think the more the data set you have, I think it figures out. You don't look at it.
The fact that question that you might ask that about nouns, say talk about row versus weight, then that must have been present in the training data.
Right, so I'm just saying you're stuck in the problem that you have to train on the corpus that you're testing on, otherwise you're never going to find all the
Not
proper
necessarily.
nouns. I mean, you can take a database of 2 million proper nouns all over the world, and then maybe you have something that otherwise.
See, the point I think all of us, I think we need to understand. If you ask a question and the answer, the model has never seen the correct answer in the huge massive corpus, then I don't know whether it actually can predict the correct answer. And that's not even the purpose. I think in the first place, when you say question answer in the whole world, let's say you train the model in Wikipedia, you are giving the lots and lots of data, uncurated rather, just random data, and then because the model becomes an intelligent model, it will figure out what the answer is instead of you browsing through the whole text, but the answer has to be there. So you actually have told the model what the answer is. For example, in the Babbitt set in Facebook in a different paper, let's say Sally went to the kitchen, John went there too. It was bright morning. Sally picked up milk, and Sally said hi too. The corpus or the context actually has the answer, but model does not know Sally said has to be a human being, and it has to be the human being in the same place. So where is Sally? Sally is in the kitchen, and who else is in the kitchen? John is in the kitchen. But you have not mentioned John is in the kitchen, but you just said Sally went to the kitchen, John went there too. So John went there and saying two, and figured out John and Sally are human beings, and hopefully they're saying hi to each other. So that's what I think. So you have to give the answer. The answer is there. You just have to figure out what the answer is. Okay.
In the interest of time, I'm going to ask that you finish the presentation.
Yes. I think this is my last slide. Just lessons and errors and some of the problems that get up to a lot of time. I think if you look at my code, entire code is only 1,300 lines, out of which the model is only 40, 50 lines. That's it. The rest is all data prep, data manipulation and stuff. We had lots of the models and the batch vectors. We created once and stored it, so that when you're doing multiple trainings, I think it was easier for us. I did not see a correlation of the LSTM size versus accuracy. Sometimes a lower LSTM size, I think, enhances the speed. So sometimes even I went as slow as LSTM size 4, but I've done 1632, even went up to 256 or even 512. 512 takes so much time, but didn't show any dramatic positive impact on the accuracy. Size of the context of the accuracy, we had 10 lines, we had 20 lines. I didn't see any spectacular difference in the accuracy of prediction. So if I even give a smaller context, it still predicts accurately. Training was test accuracy was close enough for us in our case. Hyperparameters, as I mentioned, LSTM size, we changed. We went through a bunch of optimizers, regularizers, and isolation functions. Learning rates too. Learning rate was as low as 0.1, as high as 0.1, as low as 0.0001. The model reached its peak accuracy within the second epoch, which is very interesting for us. I later on I figured out too. I tried 5 epochs, 10 epochs, 20 epochs. Second epoch, it's done. You don't need to. So the entire data set, if once you go through data set twice, it figured out. It did. And there was no, I was worried about the overfitting, and then we did not do an early stop. But I figured out the 2 epochs were just fine. Batch sizes were, because I used Keras on TensorFlow, and there is a function called train on batch, so I don't need to actually do the batches on the fly. I just actually input batch as an input because I'm training on a batch. So that was easy for me. So the context and query concatenated in that sequence versus query and context concatenated in that sequence did not show any difference for me in the accuracy. Padding in the vectors, because I had to, the context length I had to minimize, because when I had context size of 600 tokens versus some contexts or some stories had only 200 tokens. If I had taken 600 to 200 and then I had rest of them being padding 400 vectors as zeros, the accuracy actually was lower. So actually I had to pad only a fewer zeros. I did not try, as I mentioned to you earlier. I always pad the zeros to the bottom of the vector, of the matrix. I never tried first the 0 vectors and then the token vectors. I did not try. That's it from my side.
Thank you.
So you mentioned you did not use a GPU. What was stopping you from, like, you were using TensorFlow, right?
In India, we say this, we don't have money. I didn't got a chance to access the GPUs. I went for a training the other day at a conference, and they gave me a free $1,000 credits of both Amazon and Google Cloud, so I'm going to use it now. I just didn't use it.
So let's say an hour of like, I don't know, key instance or whatever, representing this on AWS is probably around 8 hours or something like that. Whatever you're doing for a day on a desktop will probably take an hour or two on that instance, like $16
You're right. You're right. I was a full-time guy. There's a couple of guys who are doing part-time in my startup, and I tried once AWS. I think for me to set up the instance and putting it was taking a little too much time, especially not just instance creation, but I think uploading the whole data set into the cloud. It was taking more time, and maybe I just was not too keen on that. I knew I could do faster than GPU, but like for example, if it runs the whole night, let's say I do it before I sleep, so at least I was sleeping longer because I know I cannot do anything. So I run the model in the night and then go to sleep.
So all the questions have required one word answer.
Yes. At this point of time, yeah, that's what I've done. Yeah.
So, but in the legal domain, we'll be looking at long answers.
If you look into the research right now, I think all the published papers, whether Facebook or in Microsoft Research or even in Google, the models are all trying to find out the one-word answers at this point of time. But the questions are becoming more complicated. Instead of just picking one word right away, it actually has to interpret multiple sentences and figure out. But right now, the answers is still one word.
So in terms of the actual corpus construction, you just pick like 20 lines, and then the next line is the question, and you're just trying to predict the last word of that line?
Not last word. We replace a noun in that, we find a noun in that sentence, replace that with a placeholder.
Okay.
The figure that you showed in the graph, that the accuracy was for the first epoch, or was it for all subsequent epochs?
Second epoch. By the time it's second epoch, I get the accuracy rates, the numbers were mentioned.
So
By the first epoch, I think at the end of the first epoch, I think it used to come 56, 58, and then
when you start, the accuracy starts at 1 point something.
that is just one particular second epoch. I was showing the second epoch.
But then shouldn't you start it with the model at the end of the first epoch? Like when you start the second epoch, the first model that you start with is the model that you have at the end of the first epoch. But that got an accuracy of 1 point something?
No, I'm trying to understand the question. So I run 2 epochs, so that means I'm running the entire data set twice on the model. At the end of the first epoch, that is on the 22 batches on the first epoch, I would get, let's say, 50, 60, and then it starts from there.
When you start on the second epoch, the model that you use at the very beginning, that is the model that you have at the end of your first epoch.
Oh yeah.
So
Same model.
if you look at the accuracy curves that you had, the first accuracy value was 1 point something, and suddenly it jumps to 56, and then it stays somewhere there, and then finally goes to 70.
Good point. So you're right. So I had 5 LSTM models and 5 bi-LSTM models, and I picked one where, in some cases, within one epoch, we were reaching the accuracy rate of that. Maybe I would have picked at that. So, but all other many models actually were reaching the point I'm trying to make in the epochs is after 2 epochs, there was no need for any further training. I did 5, 10, 15, even 50 one day. I trained the whole night.
If we see the graph for the third epoch or the fifth epoch, would it be like stuck at 72 for the entire?
No, it fluctuates, but it starts with, let's say, 50, goes down to 30, 20, 30, 40, 50, 54, 70.
And the final version.
Final version. So it goes from 60, 65, 72. I think the last 3 batches, that's what is the typical trend I've seen, but it fluctuates a lot. So even though it ends, let's say if I go for a 5th epoch, after the 2nd epoch I reach 70, and the 3rd epoch starts, maybe it starts with 50, maybe 40, and goes down, goes up and down.
But then, can that mean that the last 3 chapters, the questions for the last 3 chapters were just easy, and the model was really good at those 3?
I don't know, but when I read about this early stop model approach, which has been people are talking about, I think that's what it is. I think after the 2nd epoch, there's no need for further testing because it's.
No, but the early stopping is being done to prevent overfitting. That's a completely different paradigm. The one way to check that would be you train a model, say just 1 epoch, and you test it. Then you train the model for 2 epochs and you test it. And you should see the final curve that the accuracy should be going up as you're having more and more epochs till at some point, and then it starts going down. That is overfitting.
Sure. I think there are so many reasons for overfitting. I think we can talk offline, so so many reasons on how to figure out overfitting. I mean, even the training versus the testing accuracy, and when the loss versus the accuracy, etc. There's so many ways you can figure out. I did not try. What I did not try, maybe I should go back and try that, is if I do with only 1 epoch, train on 1 epoch and then test it. Minimum I tried was, I did once 1, but good number of times I did, minimum is 2, and then I went to all the way once to 50, but didn't make any impact in that case. But I'll go back and check with that. Thank you very much, guys. Appreciate it.